Hey y'all, it's Latrell, your favorite math coach from Knowledge Over Grades. And today I'm going to be sharing with you 8 concepts you need to master in order to pass algebra. Okay? You gotta know it. If you don't know, then I don't know how you're gonna pass. So you probably think I'm about to tell you some stuff that's in algebra, but I'm not. I'm going to be telling you some stuff you need to remember from the past for algebra. So maybe skills from pre-algebra, basic math, arithmetic, like third grade math. Yes, math builds on itself. So what you learned the previous year, you'll need to know for the next year and the next year and the next year in algebra, geometry, algebra 2, calculus, statistics. You're going to need to know all that. So it's important that you remember from the past so that you can apply it to the future. The problem is so many of us forget what we learned in the past, and it's hard to move forward because it's like literally not in your brain anymore. It's not there. So what I'm going to do today is share with you those 8 concepts. And how do I know that there are 8? Why? Because I used to be a teacher. I used to be a tutor, substitute teacher. I math coach for a summer camp. Okay. Students would get stuck on these same algebra problems because they forgot the same basic math problems or basic math concepts and skills. And I kept seeing them over and over again. Didn't matter which student I was working with, didn't matter which subject of math, they were still getting stuck on these same concepts. So that's how I know. And that's how I know that you probably clicked on this video because you need help with these concepts too. All right, so about to get into them, but before I do, I want you to hit the subscribe button because you're going to want to stick around for the slew of algebra videos I'm about to be uploading. I already got a schedule set up, and you're going to be getting a lot of help in your algebra class if that's what you're taking right now. So hit subscribe, hit the bell next to it so you'll know when I upload a video. You can go ahead and watch it. And let's get started with these 8 concepts. Number 1, you need to remember prime factorizations. What's prime factorizations? That's when you are dividing a number down to its primes. What are primes? Primes are numbers that can only be divided by 1 and itself, and that's it. Like 2, 3, 5, 7, 11, 17, 13, 23, and 19. Okay, so it gives you a general idea of what primes are. They go on forever, but when you know that you have divided your number down to primes, you know that because that means you can't divide anymore. So the opposite of primes are composites. That means you can keep dividing. Those are numbers that can be divided by 1 itself and other numbers too. So 4, for example, 6, 10, 15, 9, 21. Okay? So you probably have seen the factor tree where it's like the number up top and then it branches off to other numbers and then keeps branching down. So that's what prime factorization is. You gotta know how to do it. When will you use prime factorizations? Well, when you are simplifying a radical, so square root, cube root, and you're going to need to be able to use prime factorization to do that. Okay. So number 2, greatest common factors. Oh my goodness, that's a throwback, right? Greatest common factors come up though. Let me show you. What is the greatest common factor? First of all, that's when you have 2 numbers and you're able to factor them, so they're composites. Factoring, like we just said, divide out. And you find factors, the greatest of the factors that they have in common. It's pretty simple to do. When will you use greatest common factor? You're going to use them when you are factoring polynomials. So there's this thing called greatest common monomial factor. That means that you have numbers in, or not numbers, but terms in parentheses. So an expression of terms grouped in the parentheses. And you want to find a monomial that is a factor of each one of those terms inside the parentheses. And then you divide it out of each one of those terms, and it sits outside the set of parentheses because you divided, and you want to represent that it's being multiplied. Like you can multiply it back into that set of terms. Okay, so you're gonna need to know how to find the greatest common factor. Elementary stuff, but it comes up again. Next one, number 3, least common multiple. So least common multiples are actually the opposite of greatest common factors. Multiple, if you think multiply, that's what you got to do. So you have a number, you find a multiple of it. So 2, a multiple of 2 is 4, 6, 8, 10. Those are multiples of 2 because you're multiplying by 2 more than one time. So when are you going to use least common multiple? Well, you ever heard of LCD? It's the same thing. So in rational expressions and rational equations, you have to find the least common denominator, which is the same thing as the least common multiple of the denominator, okay? That's why you need to know least common multiples. You need to know how to do least common multiples so that you can simplify rational expressions and solve rational equations, okay? Number 4 is working with integers, okay? So integers, let's define them. So you know whole numbers, right? They start with 0 and go all the way to positive infinity. Nothing in between the numbers. So you have 1, 2, 3, 4, 5, all the way to positive infinity. No decimals, no fractions, no partial numbers. Those are whole numbers. Now, integers also include negatives of those whole numbers. So -1, -2, -3, -4. So you just have a wide spread of numbers from negative infinity all the way to 0, all the way to positive infinity. Whole numbers and their negatives. Those are integers. Now, the problem comes when you need to do stuff with them together. Sometimes you need to add and subtract them, and I recommend using the number line. I don't care how old you are. If you think it's little kid, if it's elementary school, you need to change your mindset because number line will save you, okay, when you add and subtract in integers. Multiply and divide. You got to use specific rules in order to multiply and divide integers correctly, because you're working with positive and negative numbers. So when do you use integers? Well, you're going to use them everywhere all the time because they're numbers. Like, they're in math. It's math. It's in every expression, in every equation. So you're going to always be running into a negative number plus a positive number, or a negative number plus a negative number. Those are annoying, but you gotta know how to do them. Another note on that, sometimes when students are solving equations and they get a negative answer, they think the answer is wrong just because it's negative. But that's not always the case. Like, if you did it right, if you followed all the rules, applied all the properties, then you know that your answer is right. You can do it again just to see if you get the same answer. But if you get a negative number, that's fine. That's just like decimals or fractions. If you get those as your answer, then that could be your answer, okay? Now, number 5. Number 5 is fractions. Our beloved fractions. I know you hate fractions. And almost every student I worked with just loathes fractions, but we can't avoid them. we need to learn the rules. You're going to need to convert fractions. You're going to need to simplify them, change them to a mixed number, change them to a improper fraction or a fraction greater than 1. You're going to need to add them, subtract them. That's like usually the hardest part when it comes to fractions, adding and subtracting them. Multiplying, dividing, you got to do that too, but you just got to remember a quick rule, okay? But you're not going to be able to avoid fractions. Sometimes you end up creating a fraction when you're trying to solve an equation, like you divide, right? Divide on one side, divide on the other side, and you realize you can't simplify. It becomes like 3/4, and you can't simplify. Now you got a fraction, and you try to hurry up and erase that and try to find another way, but you realize you got to deal with it. So you might as well learn how to deal and work with fractions. Number 6 is exponents. So with exponents, a lot of people think that you multiply. A lot of people think you multiply the base by the exponent, and no, that's not what exponents is. If you want to multiply, you'll know 4 times 3. But if it's 4 to the 3rd power, that's something else. That means you're multiplying 4 3 times. Okay, so it's 4 times 4 times 4. That's what exponents do to a number. And when do you use exponents in algebra? Well, let me show you something that a lot of students mess up on. They apply the wrong rule in this situation, but I'm going to show you how to do it the right way in algebra with a polynomial. It's raising a polynomial to a power. Let me show you how to do it the right way. So exponents have many, many rules, but here is the basic, like the first rule of exponents. You have 4 to the 3rd power. So that means you're going to multiply 4 times 4 times 4, okay? And 4 times 4 is 16, and 16 times 4 is 64, okay? So 4 to the 3rd power equals 64. Cool. You cool on that? It's not 4 times 3. It's not 12. It's 64. So let's take a step over to algebra. And we have x plus 3 to the 2nd power. What I see a lot of students do is this right here. X squared plus 3 squared. No, no, no. We're not doing that. That is not a rule that is anywhere in anybody's textbook. This is how you do this. You follow the same rule. So you actually are multiplying x plus 3 twice. So you got x plus 3 times x plus 3. And that is x plus 3 to the 2nd power. You're writing it twice in multiplication. Now from here on, you'll probably use FOIL and simplify and do things like that, but that's how you exponentiate a polynomial. You write it however many times the exponent says, that's how many times you write it in multiplication, okay? Number 7, we are going to now talk about radicals. Totally rad, dude. So radicals are the opposites of exponents, actually. So you saw when I raised 4 to the 3rd power. Well, if we take the 3rd root of 4, that's going to cancel out that exponent, and you're just going to be left with 4. So what a radical does is it roots out the number that is being raised to a certain power or exponentiated. Whenever I type in exponentiate, the computer says that that word does not exist, but it makes so much sense. Like, why wouldn't exponentiate be a word? But when you exponentiate a number, you can undo that exponentiating with the corresponding radical, okay? So you have square root, cube root, 4th root, 5th root, 16th, you have anything, any root you want to have, nth root. N stands for any number. And as long as it corresponds or it matches the exponent of the number inside, then they can cancel. So this is what a radical looks like, just regular. If you see a radical without a 2 or without a number right here, then it's square root. If you see a radical without any number right here in this spot, then it's square root. But if you see a 3 there, that means it's cube root. It's always going to have a 3 or a 4. But if it's anything besides the square root, then it's going to have that number there. Okay. Now, what I was saying about it being the opposite of exponents, this is what I mean. So say you have the square root of 5 squared, right? So this index is what this number is called, of the radical cancels out the squaring of the 5. So you can cross those out, and all you're left with is 5. It roots out the number that is being raised to a certain power, okay? Now, this is really basic. Sometimes you're going to have to use prime factorization, like I mentioned earlier, to reveal that number that is being exponentiated that matches the index of the radical. Got it? Got a question about that? Leave it below. And I have also a solution to your question in a few minutes. So when will you use radicals? Well, the quadratic formula that has a big old radical in it that has a whole bunch of stuff under it, and you need to use the next thing I'm going to talk about to simplify that stuff, and then use a square root to root out the number that is being raised to a power. Okay. Also, you need it for what else did I write down? Radical equations. Radicals. You got radical equations. So you need to understand the properties of radicals. The last thing I could think of real quick was Pythagorean Theorem. So remember a squared plus b squared equals c squared? Yes. So that means, say we got this right here. We got this situation. This is a right triangle. This one. This is a right triangle. And my face is in the middle of it. When you have a right triangle, you want to find the distance between my fingertips, which is called the hypotenuse. And what you do is, this side would be A, this side would be B. So the length of this hand squared plus the length of this hand squared is equal to, you add those two together, and then you find the square root of them, and that is the length of fingertip to fingertip. So that would be your C. And that is another place where you use square root or a radical. Well, in this situation, for Pythagorean theorem, it's always going to be a square root, okay? And last but not least, number 8. So number 8 is order of operations. This is so fundamental. I'm going to tell you right now that order of operations show up everywhere in algebra. Everywhere. It's like integers show up because they're numbers, and order of operations show up because you got to do something with those numbers. That's how that goes. So the order in which you operate matters. And a lot of us use a acronym to help us remember which order or what the order is. US students use PEMDAS, and there are some other variations of PEMDAS. And in order for us to remember PEMDAS, we say, please excuse my dear Aunt Sally, because those words stand for the letters in PEMDAS. And what does PEMDAS stand for itself, like in math terms? Parentheses, exponents, multiplication, division, addition, subtraction. So that's the order from top to bottom, from P to S. That's the order that you operate when you have an expression, okay? Now, I looked on Wikipedia to see the different variations or the different acronyms that other people use in other countries. And I found it very interesting. So hopefully Wikipedia was right with matching these acronyms with the right country. So it said BODMAS is used in India, Bangladesh, Australia, UK. Does that sound familiar, guys? If you use BODMAS or whichever one you use, put it in the comments below, because I would like to see the different variations that there are for the order of operations. So there's BODMAS, that would be brackets. So we use parentheses, and BODMAS is brackets, and O is order. Order is the exponent. And that makes sense because degree is also represents the exponent or the degree of a polynomial. So there's different ways of saying exponent, apparently. And then there's BIDMAS, BIDMAS, and that is used primarily in the UK also. And they have B for brackets and then I for indices, and that would represent the power or the exponent of a number. Next is BEDMAS. So once again, we're using brackets, and the next letter is E, which is exponents, and PEMDAS uses E for exponents. And that's used primarily in Canada and New Zealand. That's what Wikipedia said. So comment below if that's right and which one you actually use and like. Another one is GEMDAS, so with a G instead of P or B. And GEMDAS, the G stands for grouping. So not brackets, not parentheses, just grouping. However you want to, whatever you want to use, you group those numbers together somehow. Okay, and everything else is pretty much the same with multiplication, division, addition, subtraction. Okay, or yeah. So comment below with the one that you like to use. If there's one that I didn't mention that you use, comment below, because I want to see all the different variations and how they work and how I can apply them, because I might be able to use a way that's more efficient. Another thing about PEMDAS is that I got a little problem with it, and I'm actually going to explain that more in another video. So make sure you subscribe so you can be notified when I upload that. It's going to be in a little bit. So that was all 8 of the concepts that you need to brush up on for algebra so that you can pass it with flying colors. And let me know in the comments which one you need to practice the most. Well, if you feel like you need a refresher, which you probably do, I have created this course that's easy to understand and rather entertaining, because I like to include stories and things in everything I teach regarding math as much as I can, or relate it to something real that you can actually grasp and apply. And I created a course called Algebra Readiness. Don't you want to be ready for algebra? So in this course, there are quizzes, visuals, stories, downloads that you can take and use for the first 7 out of these 8 concepts. That's a lot. That's a lot of refreshing you're going to be getting. You don't want to be sitting in algebra just in a daze because you literally don't remember anything or much of anything that you learned that you need to apply to these new concepts that you're learning in your algebra class. You want to be able to know what's going on. Call those concepts back to memory by using the Algebra Readiness course as a supplement to the course you're taking now, so you can go ahead and ace that thing, okay? This course is for you if you are studying algebra on your own, in class, if you're being homeschooled and you need some extra support, or if you want to brush up on some basic math skills so that you can apply it in daily life, or just for fun because you like math like me. If you're interested in this course, you can learn more about it by clicking the link in the description of this video. And I think that this will be really helpful in strengthening your foundation so that you can understand what's going on in your algebra class, which will increase your grade and increase your chance of passing the class and not thinking, oh, only the smart kids pass these types of classes, or only the smart kids get A's, I get D's. No, you can get a high scoring grade in it as well. You just have to boost the bottom line up, get that foundation strengthened so that you can finally get out of that class yourself. Now, I've enrolled over 100 students into the first version of this course, but I've redone the whole thing and it's even better. Check out what Steven said about the course. Steven said, I really like how you have everything set up. It's like you start us off learning all the basic fundamentals before we go on to algebra. At least you don't have us jumping and skipping all over the place. It's organized and done in baby steps. So thank you, Steven. And if Steven likes it, I'm sure you will like it too. So go ahead and enroll, use it as a supplement, as something to help you, as a tool to help you through your algebra class. You can enroll with the link in the description of this video, and I hope to see you inside.